one-sided limits. Okay, so if we have a graph, a function like this, let's say this is function f of x. So when I approach from the left, that we represent as limit x tends to c, and we put a minus here. F of x. That means when I'm approaching c from the left side, what is the limit of the function? If I'm approaching from the left side, then I am on this part, right? I am moving on the graph like that. What is that limit? L, right? As you go coming from here, you're coming from here, and you're going to L. And when I'm approaching it from the right side, I am on this part. Limit x tends to c plus. Plus is from the right side. What is that? That is m. Left limit or left hand limit? Limit from the right. Right? And we say the limit exists. Limit x tends to c, no left or right, right? Fx exists if the left limit is equal to the right limit, right? If the left limit and right limit are equal, then that is the limit. If they're not equal, then the limit does not exist, right? And it has to be finite. If it is like going to infinity, then again we say it doesn't exist. We can say it's infinity or negative infinity, but in reality, the limit does not exist. So let's look at continuity. We talked about continuous functions in an informal way earlier, right? So if this is a function and I'm checking here, right? What's the meaning of continuity? That the function has a value here, right? And from the left and right, it approaches the same place, right? Then it will be continuous. Because if this value does not exist or is a different value, then you will have a situation like the value is here, right? Then it's broken, correct? Or if you approach different spots, then again it is broken. Or you don't approach anything finite, then again it will be broken, correct? Continuous means it's not broken. So we'll look at these scenarios, but let's formally define what it means for a function to be continuous at a particular place. When f of c is defined, right? That means this value exists. It can't be like there is no value at c. There's a value of the function at c. 2, limit x tends to c, f of x is also defined or exists, right? That means from both left and right, it's coming to the same limit. And third says these two have to be equal. So we can find whether a function is continuous at some point by checking that is there a value of the function at that point? Does the limit exist? And are those equal? The value of the function and the limit. If all of these three conditions hold, then the function is continuous there at that point. Suppose f of x is absolute value of x minus 2, right? So if it's absolute value of x, it looks like this, right? This is absolute value of x. But if I do x minus 2, what happens to this graph? For any function, if you replace x with x minus 2, let's say, then what happens to the function? I think you've studied transformation of functions, right? If you have some function, this is f of x, then f of x minus 2 will shift the whole thing right by 2. So it shifts the whole thing right by 2. If I did fx minus 2 outside here, then that is y minus 2, right? F of x is y. Then the whole thing will go down. But x minus 2 will shift it right by 2. X plus 2 will shift it left by 2. So this whole thing will shift here. That. So that's the function we are talking about. So I want to find at x equals 2, is it continuous? So first thing I will check, those are 3 conditions, right? What is f of 2? F of 2 is 0 because 2 minus 2 is 0, absolute value of 0. Right? So you see from left hand side, from right hand side, what are they approaching? 0. So if you know the graph, you can do from the graph. If you don't know the graph, then you'll have to find the left limit, the right limit, and check that they are equal. And then third thing you check is these two have to be equal, right? Which is true, correct? Both of them. So it is continuous. That is how you will check whether any function is continuous somewhere. You check that the function is defined at that x. You will check that the limit exists at that x. And then you'll check that those two things are equal, the value and the limit. If any of these conditions fails, then the function is not continuous there. Because if the function is not defined there, then that means there's a break. Or if the limit does not exist, it means, it's going in two different places from left and right. Or maybe it's just not defined. There is no limit, like it's not even in the domain. Or third case can be, there is a limit and there is a value, but they are different. Then there is a break. So based on these situations, we can get different kinds of discontinuities, right? So let's look at discontinuities. Discontinuities are categorized into two kinds. One is called removable discontinuity, and the other is called non-removable. So removable means I can change my function value at one point and then it will become continuous. Then that means I can remove discontinuity. So, right, so it would be typically a hole like that, right? So if I put a value here, then it will become continuous, correct? Right? If I change the function by defining its value to be this same y, then it will be filled in, then it is continuous, right? The non-removable means the limit doesn't exist. So you have something like that. Now I cannot just change one value and make it continuous, right? I cannot put this dot here. It will still be discontinuous, right? Because the limit doesn't exist. Here you're coming from one side, here you're coming from another side to a different point. So if the first condition fails, right? If the function is not defined there, we could still be able to fix it, right? Because if it's a hole, we might be able to fill it, right? But if the second condition fails, the limit doesn't exist, then it's non-removable. Then we cannot do anything more. But if the limit exists and the limit is different from the function value, or the limit exists, but the function doesn't exist, then it is removable. So doesn't exist, continue testing when we are looking for discontinuity. That's okay. Then we say, okay, limit, this doesn't exist, then it is non-removable. Right? We don't need to do anything more. We already know we cannot remove it. But if it exists, then you continue. Then you keep checking, right? Then you come here. So if these two are not equal, either this doesn't exist or they are not equal, then this is removable, right? Because just by changing f of c, we can make it work. So first one, is it continuous or discontinuous? Discontinuous. So this is discontinuous. So the limit doesn't exist, right? That's the condition that is failing. So is it removable or non-removable? It's non-removable. If the limit doesn't exist, it's non-removable. What about this? Is it continuous or discontinuous? There's a break, then it is discontinuous. Any kind of break. So it has to be discontinuous, right? See, whole means there is no value for that there, right? So f of c is undefined, but a limit exists, right? So here, if I put one dot here, then it will become continuous, right? Okay, and is this continuous or discontinuous? No, so it's discontinuous. F of c is undefined. What about the limit? Limit doesn't exist, right? So if limit doesn't exist, you don't need to do anything more, because then you cannot fix it. Non-removable. Because I cannot fix it. I cannot give one value at c. Suppose I give f of c is 5. It's not going to work, right?